Hello everyone. The webinar will start in about 5 minutes. While we're getting ready, we'll wait for everyone and start. Hi there. We can get to know everyone for now. By the way, let's agree on how we will ask questions. You can write them in the chat. You can probably raise your hand. And in 2 minutes, let's get started. Let's have someone write to the chat, just in case. How well can you hear and see us? Thank you. So, well, let's get started. I welcome everyone to today's webinar. My name is Nikolai, and I am the head of one of the teams in the Yandex Go data management platform. My name is Vladimir. I manage our platform as a whole, which is used in several business units. And then, probably, I can pass the word Kolya. Kolya will talk about how we work, what we work with. Okay, good. Today I'm going to tell you how we use YTsaurus to build storage inside Yandex Go. And our report will, in fact, consist of 3 basic main sections. In the beginning, I will tell you about how the Yandex Go taxi data warehouse developed in general, what kind of architecture we came to. Then I will briefly, as far as possible, tell you about the main capabilities of YTsaurus. And in the main part, I will tell you how we land what we invented inside the very entrance of YTsaurus. So let's start with the architecture and the way of the taxi data warehouse. In fact, it all started quite a long time ago. At that moment there was no data warehouse, there was only a backend, there were bases, and there were replicas of these bases, to which analysts went and made some of their analytical queries in order to answer questions that are required for business. Given that there was no data warehouse, we do not know the exact date, so the point is somewhere in the middle between the 2011 and 2016 years. Around 2016 year, the first such production data lake appeared on technology, which I will not tell you yet. But probably everyone is already proving that we used it. At this moment, some scheduled launches have already appeared, the makings of a Python framework have appeared, and, in fact, such a data lake has appeared. In the 2019 year, a full-fledged data warehouse has already appeared, in addition to the data lake. We also have production processes left, cron. At that moment, a full-fledged data management platform appeared, and we began to develop a little independently. One team develops data warehouse, the other team develops a data platform. Actually, now I'm going to tell you about the architecture we adhere to. It is possible that some of the listeners have already seen some of the Yandex Go reports concerning data warehouse. And therefore the picture they will see now is already somewhat familiar. Initially, the architecture of the layers was designed and imprinted into granite by Yermokov, who was the architect of the data warehouse. And each layer defines a verb that will be applied to the data. In other words, at the beginning we collect data. This is a raw data layer. Its main purpose is to save information from the source, that is, to take the data as it is and convert the format, which is sufficiently resistant to change. The next verb is to standardize. In other words, in this case, we also transform the objects of the original system. We get a more normalized form. It is much easier for an analyst to use this. For example, through some kind of SQL or similar tool. And the purpose of this layer is to store operational data. The third layer is the DDs, that is, it already saves data. In other words, we accumulate data about entities in a domain model. We consolidate data between different sources, and also provide a scale-like interface so that this data can be accessed. The next layer is the common data mart, that is, it is a layer of basic data marts that provides access to our data for analysts. Here we form data in the context of business consumers and optimize read access. The next layer is the report layer, which operates with the verb analysis. And we call the layer rep. In other words, there are already more detailed reports for specific business units that implement the specific needs of a particular unit. Thus, we currently have 5 layers in the data warehouse. These are raw data, operational data, a detailed layer, a data mart layer, and a presentation layer. Accordingly, we collect raw data using a replication service. This is an independent service that is also written inside Yandex Go, which allows you to take increments from different sources from different types, that is, SQL bases, not SQL bases, some kind of API, and convert the data to a format resistant to changes. Accordingly, ROW and ODS is our data lake, that is, it is semi-structured data and a MapReduce carcass. As a calculation framework, the ODS, DDS, and CDM layers are already a full-fledged data warehouse. Various ad hoc requests are executed on it. There are a lot of joins about it, and we expect that there will be a fairly short response time. CDM and REP are already for full-fledged data analysis and visualization. In other words, these are more data cubes, reports, and dashboards for biosystems. And now I'm going to tell you about what is YTsaurus. Inside Yandex, we call it YT, so during the webinar, I will constantly use these two terms, but in fact they mean the same thing. That is, it will either YT or YTsaurus. YT is YTsaurus, a product for distributed data storage and processing. It appeared in Yandex more than 10 years ago, and it is provided as a service within the company. In other words, any team can order resources, get them, and start using them. Recently, this project has become open source, and now it is available to external customers. Accordingly, it is convenient for sending ad hoc requests for machine learning calculations, and has a powerful interface for both the user and the administrator. What are the key elements of YTsaurus? First of all, it is a Cypress. It's a strange enough word, but a little further, I'll tell you about it in a little more detail. These are tables that store information from certain transaction data, within which this is performed, quotas that we operate with, and a CL. A C50 is an access control list, that is, it is a subsystem for controlling user access to various objects. Now let's look at each of these elements separately, in order to understand a little better what opportunities they can provide for us to build a data warehouse. Cypress is a tree of meta information inside YTsaurus. In other words, it is somewhat similar to the file system tree, but it has a number of differences. Firstly, a set of attributes can be associated with each node, which is convenient for various user add-ons. Secondly, it is transactional, and the nodes of this tree can be either directories, files, tables, or links to other tables. In other words, YTsaurus is the file system of YTsaurus. What are the tables like? There are quite a lot of different types of tables, which are used somewhere by some, in some cases by others. But all tables are divided into static and dynamic. A data scheme can be defined inside each table. There is an additional type that is very actively used in YTsaurus, which is called YSON. And I'm going to tell you about how positioning actually takes place inside YTsaurus. What are static tables? This is the main type of YTsaurus tables. They are almost impossible to change. Here, probably the key word is almost, but. In other words, you can add a little bit to them with certain nuances, but in general they can be considered as a complex modifiable object. Inside, each table is divided into chunk, and each chunk can be either columnar or row-by-row. In other words, it is determined at the moment of creating the table, but at some point it can be decided that all subsequent chunks will become of a different type. Then the table will have a double-double type. Part of the chunk will be columnar, part row-by-row. This is a normal situation. Static tables themselves are of two main types, sorted and not sorted. At the same time, sorted tables may be able to indicate that the key in the sorting is unique or is not unique. Accordingly, what is a sorted table? First of all, it has a set of key columns defined. The data inside this table is always ordered by key, and this allows for an efficient search by key. In the data schema, you can specify that the sort key is unique. And then YTsaurus will ensure that there are no duplicate elements inside the sort key. In fact, it's naturally not free. And in order for the table to become sorted, all the data must be sorted before filling in the table, which in principle is not the cheapest operation. The next big type of tables are dynamic tables. Dynamic tables are a type of YT tables that implements a point-to-point interface for reading and writing data by key, and supports a transaction. There are also their own SQL dialect. That is, in this way, the presence of dynamic tables allows you to implement a typical key-value storage. Dynamic tables are of two types. They are either sorted or ordered. Sorted tables, respectively, they have exactly the same sort key as sorted static tables. The key is always unique, and it is important that a transaction is supported inside dynamic sorted tables. Each table has a data scheme. It describes the well-known columns and their types. It is set when creating a table and can be either strict or not strict. That is, if the table is strict, then only data in which can be written to it. Then it cannot be written to data in those columns that do not have a scheme. If the scheme is not strict, then it is allowed accordingly. And also the scheme has a unique keys attribute, which can be either true or false, and, accordingly, it determines whether the sorting key is unique or not. YSON, this is such an analog of the JSON format. The main differences are that it supports binary representation of scalar types and that you can hang your own set of attributes on any element of a node. You can listen to a separate report about YSON, which was in 2023 year at the C++ Rush conference. And it was told to you by Ivan Smirnov from Yandex, and there it is told in more detail about YSON. From our point of view, this is basically an analog of JSON, which you can work from Python, C++, Java, YQL. Well, almost everywhere. How is partitioning in YTsaurus implemented? It's not out of the box. That is, there is no partitioning by default. And users implement partitioning themselves. That is, one entity, one directory, the way we do it. And one partition is actually one file. Thus, all partitioning support falls on the users. And with not quite accurate work, we can assume a situation where we have one set of columns in one partition, another set of columns in another partition, and from the point of view of YTsaurus, this situation is correct. And this situation completely falls on the data engineer who works with the system. The next important feature of YTsaurus is transactionality. There are two types of YT transactions. First of all, these are transactions in Cypress and transactions inside dynamic tables. And now I'm going to tell you a little more about each of them. Transactions in Cypress. Firstly, they fully correspond to the OSIT model. All actions on the Cypress node can be performed inside a transaction, and a blocking system is implemented to work with nodes. There are three basic types. This is a snapshot. It means that the transaction can read, but cannot modify. So this is that transaction. The transaction notifies that it plans to work with this node. An exclusive transaction, accordingly, can modify a node and other transactions cannot. And shared block determines that it defines a transaction that can modify a certain part of the node, for example, some subdirectories, but it does not block the entire directory exclusively, which is sometimes very convenient. What are transactions in dynamic tables? These are transactions for inserting, reading, and fetching data. In other words, it supports transactionality according to the M5CC models. By default, the snapshot isolation level is saved during each save. During any save, a timestamp is recorded, and, accordingly, at the start of any transaction, a start label is generated, which allows you to determine which data of this transaction is available and which are unavailable. And as a result, the user request always receives correct and consistent data. When reading dynamic tables. The next important part of YTsaurus is what is being quoted here. First of all, it is the CPU resources that are quoted, that is, the resources of computing power. And the second is the storage resources, that is place, nodes, chunks. What is a computational pool, and how is it limited? First of all computing pools inside YTsaurus are hierarchical. CPU, memory, and user slots are limited. In any computing pool, there is a certain dominant resource that determines exactly why the calculation of how many resources will be required will take place. By default, there is a fair share scheduler, that is, the same amount of resources is allocated for each user of the computing pool. At the same time, if one user starts executing several requests, then in this case, resources are divided for this purpose, and all the others continue to receive their fair quota. There is also a strict guarantee of how many resources the user has. There are also integral guarantees that allow you to get additional resources at the moment. Inside Yandex, this is implemented by the fact that we have a large YTsaurus cluster, which is used by many. And it is clear that at some point in time, there are idle resources. And if the computing pool has integral guarantees, then at the moment when it needs additional resources, and they are in the cluster, they are provided to it. For external users, this can be implemented through some different computing pools in different departments, and, accordingly, integrated resources will also appear in this way, which will be available to other users if necessary. What do computing pools look like? Here is an example of our test computing floor inside a taxi. In other words, we have a hierarchical pool called taxi2. It has various subpools. This is for batch loading, for priority loading, for Spark jobs, and for historical recalculations. And, accordingly, we have an example that for a taxi2 we have some kind of guarantee on processors, for memory. And it is clear that the backfill, well, it's not really visible, because I learned how to blur screenshots today. And therefore it's hard to see now. But in fact, the backfill has a much smaller amount of resources than the base computing pool had. What else is being quoted? Quoted are disk, nodes, and chunks. Why? Well, why the disk is being quoted is understandable. The question is why, for example, nodes are quoted, and what are notes in general. Nodes are elements of the Cypress tree. And, accordingly, the more nodes there are, the more difficult it is to follow all this as a master process. Well, actually, in fact, in all operating systems, it is not that it is allowed to make an infinite number of files. So this is also limited here. What does our quota look like inside the DA? That is, we have limits, we have usage and free space, which we understand is still available to us. Here too, the total volumes are not quite visible, but it is as if measured in terabytes, chunks are measured in millions, and nodes are measured in tens of thousands. An important part of YTsaurus is a CL. In other words, this is how we determine what the user can and cannot do. The control is carried out up to the nodes of the Cypress. There are users and user groups in the system, and, accordingly, both users and other groups can be members of the group. Well, that is, in principle, a fairly classical scheme for describing users. Much more interesting is that the inheritance system is implemented. In other words, the object gets the rights of the parent object if it is not overridden. In this way, you can configure a fairly flexible hierarchy of rights, which is convenient to use when creating objects. A fairly important killer feature is the column-level issue of rights, but it is not recommended to do this for all objects, but rather point by point, where it is exactly needed, because it is quite expensive for the system. And, in fact, we have come to the most interesting part of the report. This is actually how we use YTsaurus when building storage inside Yandex Go. Here we look at a few basic models. This is, respectively, the storage of information, the use of the service, and how we configure access rights. Let's start with how we actually store information. As you could see at the beginning of the presentation, we have a lot of layers, and we do not store all the layers inside YTsaurus. Therefore, it would be more correct to say that in addition to YTsaurus, we use Greenplum, this is a Postgres fork, for multi-shard work, and we also use it to store information. Accordingly, what layers do we have? Let me remind you. This is a raw layer, an operational data layer, a detailed layer, a data mart layer, and a report layer, and how they are distributed across storage systems. Inside YTsaurus, we store raw data, we store operational data, a layer of data marts, and a layer of reports. In Greenplum, we store partially the odds, because we can't upload the entire volume. We store a detailed layer, a data mart layer, which is most often considered on the Greenplum itself, and then exported to YTsaurus and the reports layer. What do we do to store the raw layer in YTsaurus? First of all, let me remind you that the main idea of the raw layer is to save the information from the source, save it as it is, and transform the format resistant to changes. So what do? We have a table, it has a strict scheme. We use dynamically sorted tables, that is, these are the tables that allow you to write by key and read by key. We have the same table structure. This is the natural key of the source system, plus the ESIN field, in which we store everything as is from the source system. Accordingly, we sort by key, and most often protectionize by month. Storage is by column. As we believe, in fact, we use a replication service that performs line-by-line insertion, a dynamic table by key, and a historical recalculation we do through map-reduce substitution of partitions or tables there, depending on the object. The inside of YTsaurus tables looks something like this. I've blurred everything here too, because I've been Googling how to use it for a very long time. And when I realized, I couldn't stop. In other words, we see that we have a column, in which we store the key, and some kind of doc field, which contains a JSON-like ESIN format. Here, accordingly, any degree of nesting is supported. It can be sheets, it can be under dictionaries. That is, here in principle, as the system stores the source, so we record it. what we get from the approximate volumes inside the raw layer. Here I would break in a little bit and add. Here in YTsaurus, there is probably an important difference from YTsaurus in that he does not have attributes. And when the source type system can be richer than the type system that is available in YTsaurus, then information about what it actually was can be written to the attributes of YTsaurus. We use this and thus do not lose information about the types to the source, which can then be useful. That is, on each node here is the YTsaurus tree of the object. There can be special attributes besides the value. I'm sorry I interrupted you. Here. No, great. So, now I'm going to tell you about the approximate volumes. Raw data. We currently have about 1 petabyte of compressed data. That's 2 trillion lines. And if we were operating with non-compressed data, it would be 10 petabytes. In fact, it turns out to be about 1,300 entities. By entities, I rather mean a specific table of the source system and about 35,000 partitions. What kind of daily increments come to us? In total, the second layer increases by about 1 terabyte of compressed data per day. For the largest object, this is taxi orders, we have about 30 million inserts by the key, and thus we have. Well, since one order can come several times during its life, then unique orders turn out to be more than 10 million per day. And thus the raw layer on orders increases by 30 gigabytes per day. At the same time, it should be understood that 30 million inserts are not just some small object, it is a YTsaurus document, which can often take up 5 or 6 kilobytes there. In other words, this is quite a lot of data. What do we get in the end? That the data reaches the raw layer within 50 minutes. Thus, on top of the raw layer in principle, it is possible to do intraday analytics, which will allow you to get data fast. In other words, it turns out that events occur in the backend system, takes it from replication in a few minutes, and also writes it to the raw row layer table in a few minutes, and the total lag time is about 10 minutes as much as possible. Well, it is clear that there are some peak loads in which something starts to lag a little, but on average, the raw layer lags 10 minutes behind the source system. The next layer is ODS. Its task is to store the operational data of the source, and here we are already forming a set of entities and decomposing them into more understandable objects. What are we doing? We also use a strict scheme, just like we use dynamic sorted tables in the raw layer. They are also partitioned by keys and are also generational, although this is not indicated here. But unlike the raw layer, we already store normalized data. That is, we arrange them in columns and put them neatly in the table. This is much more convenient for the usage analyst than YTsaurus. How do we calculate? In fact, we consider the ODS layer on our TL servers. In other words, they get some kind of increment, converts them, and just as viciously insert a dynamic table by key. In other words, the total amount of changes is actually not less than raw. And the historical recalculation takes place in the same way as in the case of row-through maps, and simply exchanging tables or partitions. What does the object look like? There are actually about 500 times more columns here, that is, the order has about 500 attributes. Here I have shown 3, but in general, this is a regular table that has understandable columns with a certain naming, and which is already convenient for the analyst to use. What is the volume? Unlike raw, we already have 2 petabytes of compressed data in the ODS layer. This is primarily due to the fact that we have a certain number of logs that we do not store in raw data, but we store in the ODS layer, and therefore there is much more data here, because the logs themselves are very heavy. And even after processing, they continue to occupy, probably, a leading place in our facilities. And here there are already much more lines themselves, that's 44 trillion lines. This is also due to the fact that, for example, we receive a complex document from the database on request, in which there are lists of candidates or some lists of tariffs, and we can't decompose it neatly into a flat table. So we can create from 1 to n different objects of the ODS layer there on the basis of one Mongo correction, in which, accordingly, more rows are duplicated, plus it is expanded in some way. Thus, there is a multiplication of the number of rows, and in this connection, such an increase in data is actually associated. If it was all uncompressed, it would be about 15 petabytes. Unlike a raw object, there are already only 800 entities and, accordingly, 44,000 partitions. Thus, the analyst has the opportunity to use a beautiful object in which everything is laid out in columns, where a certain naming and high-quality documentation is written, but if there is no field that he wants to use in his calculations, then in this case, unfortunately, he will not be able to use ODS. He should go to the cheese layer himself and start parsing the data, or, by the way, make a ticket for the data engineers, who will stretch out the fields to him. The daily increment in the ODS layer is on the order of 2 terabytes of compressed data. The lag time is about the same, that is, on a normal day, we rarely have a lag of ODS objects for more than 10 minutes. That is, in this way, intraday analytics can also be done on top of the ODS objects inside the Yandex Go. Probably, an important element of the ODS is that it is still a source-dependent system, and thus analytics is limited to the system from which this data came. And then it is necessary, respectively, to join it with something else, and accordingly, as if to independently implement the logic of connecting different objects. The data mart layer, it already provides ready-made data marts for our main users. These are analysts who make various business decisions there. Accordingly, in this case, we are already using static tables. They are normalized in the same way, and the important difference is that sorting occurs most often by date. That is, it is either the date of the order, or it is the date of the transaction. That is, it is the date of some fax. Because it is important for BI systems to quickly and as efficiently as possible subtract data. And if we sort by date, then, accordingly, when reading one day from a monthly partition, we save resources for reading. And, accordingly, the result is obtained faster in a BI instrument. So, how do we calculate? Unlike the rest of the layers, we calculate the CDM by MapReduce or by Greenplum, and then we transfer it with special means. And most often we consider them aside from the prod data, and then just taking advantage of the transactional opportunity. After the transactional substitution inside the Cypress, we carefully replace all the calculated partitions with one action. Thus, the user does not have a moment when they have inconsistent data. That is, at any moment, the user launches a request, and here the data is considered on top of the consistent ones. Its request is considered on top of the consistent data. What about the volume of a CDM layer? This is probably the smallest layer relative to the previous ones. This is only 700 terabytes of data, only 300 data marts, and like about 14,000 partitions. What is our partitioning strategy? All data marts are standard, well, if they are factual data marts, and not some kind of measurement. We try to protect them by months. For superimportant objects, we are trying to create, well, more precisely, we are now using daytime positioning, which, firstly, allows us to calculate these very data marts more efficiently, and it is much easier to actually read them to a BI tool. But here we need to understand that it turns out that if we do daytime positioning, then this entity has an avalanche-like increase in the number of parties, and thus the number of nodes occupied by this object. And therefore, since the nodes are a limited resource, we cannot make all the data marts daily, so most of them lie in monthly. The superimportant ones in daily, and the smallest ones we convert them into annual ones in order, in fact, to save the YT resources. What is the sorting strategy inside the CDM layer? We sort by date, as I said. First of all, this is important for BI tools, plus compression works a little better when we have similar data in one place. The CDM layer, unlike the ODS and row layer, we upload by batches. This happens 1, 2, 3, 4 times a day depending on the object. Accordingly, it is most often used for calculations of T-1, that is, no one is doing intraday analytics on top of data marts at the moment, and, accordingly, it is used to build various management reports. A small summary of the layers. That is, we have row ODS, these are dynamic sorted tables, CDM, this is static. And the ODS and CDM layer has a structured view, while the row has just a key plus JSON, ESON. What are we doing to use this data? In fact, this data is not only us, but also analysts. We use primarily YQL, and an additional extension to this language is CHIT, ClickHouse over YT. And SPIT, which is Spark over YT. Actually, what is YAL? It is a universally declarative query language for various data storage and processing systems. Its main feature is that he knows how to work not only with YTsaurus, but also with a ClickHouse. Perhaps now it's starting to learn how to work with something else. It's a SQ50-like language. It supports user-defined functions that can be written in C++, Python, JavaScript, and actually, the person who knows how to use an SQ50, in general, is quite easy to learn from YQL. That is, it is very similar. The basic functions are still the same. There are additional syntactic features that are quite easy to learn and to use. How can YQL work on top of YTsaurus? It has two options, MapReduce and DQ. MapReduce is a classic way of using it, that is, when we write a SQ50-like request in YQ50. Click the Execute button, it converts this request into a MapReduce operation and runs it on the cluster. Some time ago, there was an additional DQ mechanism that allows you to optimize queries, if it can do it. That is, the soundboard has, as it were, the following features. All calculations take place in memory, it can only work with static tables. Since it works inside memory, the tables should be no more than tens of gigabytes there, so that it all fits, and at the same time, supports joins. That is, if the request satisfies the DQ mechanism, then it will be used. In this case, the request will be an order of magnitude faster. If not, then we switch to MapReduce and run the standard operation. Also, star joint optimization is implemented inside the YQL. In other words, this is an optimization that, for classical star schemes, when we have a table of facts and measurements, allows us to greatly optimize the execution time due to the fact that, as it were, all these joins occur on the fly at one point in time. In other words, all tables must have, first of all, a unique key, and at the same time, the performance is enormous. That is, in Yandex taxi calculation of data mart without star join occurs within 3 to 4 hours. With the use of star join optimization, it works in 30 minutes. That is, it's just at times under certain conditions. There is a ClickHouse over YTsaurus. What is it? A ClickHouse cluster is implemented on all nodes of YTsaurus. This gives a certain bonus in that there is no need to copy the data anywhere. The ClickHouse is able to directly read the format in which the data is stored. The data is stored in these files, and, in fact, it supports both static and dynamic tables, works with YQL. Only in YQ50 it has additional syntactic features, but they are also quite obvious. And after studying them once, in principle, you can easily work with them after that. There is also a mechanism for using Spark on top of YTsaurus. Here, as with the case with the click house, well, no, more precisely, it is architecturally different. But Spark rises on top of YTsaurus, it eats away part of the resources and quotas in which Spark is launched. And within this cluster, Spark operations can actually be launched. When is it useful? When we have a complex query with a lot of queries and with a lot of. When there is a query with a large number of joins, and in this case, Spark will be more efficient, because it also does all the calculations in memory. When is it better to give it up? When we have gigantic volumes, and they definitely do not fit into memory. And when a user request actually consists of one map reduce operation, because in this case, the efficiency of Spark will be minimal. That is, in this way, if we summarize the operation by analysts, YQ50 over YTsaurus is mostly used, that is, it is directly just reading the plates through a SQL-like interface. And in certain cases there are additional mechanisms that allow you to greatly optimize your queries. That is, if we process only one entity, then we can use the ClickHouse over YT. If we have a lot of joins, but they are not super gigantic there, then we can use Spark over YT and also get a performance gain. What do we do to maintain our system? Because over time, we need to do something with the partitions, additional maintenance. And actually we transfer part of the dynamic tables to static. Because over time changes occur only in fresh partitions, and there is no sense to keep the ancient partition in the dynamic table. In this way, we translate them into statics, we save the resources of dynamic tables, and, accordingly, it becomes a little easier for our dynamic tables pool. Accordingly, the second part is the compression of old partitions inside static tables. In other words, those partitions that are rarely used, we change the code and recalculate in a more efficient compression. This allows us to actually save space and allows us to save chunks. There is a standard mechanism for compressing old partitions in YT, that is, in user attributes. This is the very feature that Cypress has. You can specify a certain algorithm, and, accordingly, YT performs compression in a computing pool at a certain time. But inside Yandex Go we have our own way, so for now we don't use it, but use our own methods to determine what we want to compress. What are we working on? What are we doing with the AC50? A C50, I remind you, is an access control list, that is, it is a mechanism that allows you to determine to which user what access to which evil of Cypress is provided. Inside Yandex Go, we configure everything at the root directory level. That is, we have a data warehouse folder, the top one. We configure the rights, and after that all objects inside all subdirectories begin to inherit these rights. Thus, inside the data management platform, in fact, we do not have anything on rights management. At the same time, if we have some object that becomes more critical, or some layer, or some subsystem that becomes more critical for access, then we simply remove inheritance from this object with the YT inheritance clause, and grant the rights that this object and all the underlying directories need. Thus, we have a fairly flexible, convenient, beautiful system of rights that does not require any additional work. Unlike DBMs, here we do not grant rights to specific files. Despite the fact that there is physical support for granting rights in YTsaurus, we do not use this mechanism purposefully, but always grant rights to the catalog. That is, even if we have a table that is not partitioned, we have a directory with the name of the table and the name, and the file itself with the name of the table. Because sooner or later someone will want to recalculate this file, and if we grant rights at the file level, then in this way, when recalculating and substituting, all writes disappear, they must be frantically searched for somewhere. Or restored from the file that we deleted and want to delete, or, accordingly, somehow from some that is the system to choose. Therefore, we are following a simpler path. We don't do a C50 at all, and that's it, but we do the C50 at the catalog level. So, the result of what YTsaurus gives inside Yandex Go. First of all, we probably use a significant part of the functionality that it provides. These are static, dynamic tables. We use ISIN very actively to store documents of arbitrary structure. We are very actively using transactions to consistently change data. We use YQL to perform transformation. We manage the nodes of Cypress from Python and launch the operation. We are working very well on computing pools so that night calculations run in the right, well, as if in the right, fit into the right window during the day. Analysts have more resources for calculations there. And accordingly, in various user attributes for Cypress nodes, in order to mark which partitions we ourselves compressed, which ones need to be compressed again, and accordingly we check all this, use many different possibilities. But at the same time, there are a number of functions that we don't use yet, but sooner or later we probably will try. In other words, we use sorted dynamic tables, but there are ordered ones that we don't use yet, but maybe we'll try somehow. There is also a regular way for partitions compressing, which also sounds very cool, and we need to try it, and accordingly. We rarely use tables inside the DO without a strict scheme so that we can write those columns that do not exist. But we haven't figured out how to do it yet, why we need it, and therefore we don't use it yet. Actually, YTsaurus holds all our volumes. As we have seen, we manage to have a fairly large number of point inserts on the key on the row. We have a lot of map-reduce operations on the CDM layer, and all this, in principle, fits into the timings that we expect. And YT is absolutely fine for us as a whole. As a data storage environment. This is where the official part of the webinar ends, and then the section, probably, of questions and answers. Yes, there is already one question for sure, but it's really not about YT. It's about airflow, whether we use it or not. Basically, can I answer while you rest a bit? No, we do not use airflow. We have a fairly old project. We started with such requirements that airflow fitted very badly. The current one actually fits better, but we have already written our own tool. We talked about it a little at different conferences. And now we continue to develop it. But it is not open source, it is only available inside Yandex. Any more questions? I do not know, it seems to me that we can even let some people in to ask a question. There is an opportunity here. So let's try to wait for a couple of minutes to see if people have any questions. And if not, should we finish? There is a question about different columns in the partitions. Is it normal? This is a bug or a feature? This is a feature of the file system that you need to know about and work with. In other words, it should be understood that this is this nuance, and when implementing processes there, it is necessary to build it so that it is minimal. Well, this rarely happened. We actually have. Such that we don't do that. In other words, we believe that a folder is a kind of table, so everything in it should have the same scheme. Just, for example, transactionality helps well in this, because we can change at least all party members in one transaction at the same time. Well, yes, but at the same time, as if on the side, we can count them for at least a month, for 2 months. And when they are all counted, count them in an instant, but replace them and everything will be consistent. So, let's probably continue the topic about partitions and columns now, and then move on to questions about Greenplum. Here, let me read the next question. Does this whole story give advantages, or is it something that needs to be monitored? It is impossible to limit programmatically. But it is impossible to systematically restrict it on the YT side, and this must be monitored. It probably doesn't give an advantage, but at least inside Yandex Go we don't use it as an advantage. Rather, it's just as a feature that you need to know. Perhaps you can come up with some tricky option when. Well, I probably won't come up with this option right away. Well, I wouldn't be so definitive here. In other words, there is definitely a scenario when it can be useful in some cases, when the scheme gradually evolves and changes somehow. The problem is that at the joints, especially in the case of a break, there may be obvious problems. Therefore, we decided for ourselves that we do not actually use those possible advantages of such a story, well, for example, not to make alterations without recalculating the history and so on, but we strictly guarantee the uniformity of the schemes. But you can work in a different way. For example, the same tools in some cases normally handle the appearance of, for example, new columns in new party members. That's it. The only thing that I said here for sure is that, for example, the appearance of new columns is normal. But the changing type from partition to partition for the same column is a very bad situation. Because YQ50 and Spark are strictly typified and do not work very well with similar stories. That is, you will have to suffer there. If we manage to answer on this topic, let's move on to the next one. The next one is yes, Greenplum. Why do we have it? Do we plan to abandon it? A trivial question. Why is it there? Because, it seems to me, at a certain point in time, Greenplum was able to do what was poorly available on YT, that is, maintain a well-normalized data model. Here, there is a separate, probably a big case question, whether it is needed or not, and in what cases it is needed, and how to work with it. We, as platform developers, try to support all scenarios so that, so to speak, in a specific task, data engineer has the opportunity to choose the most suitable tool. Here, to say that now, for example, the speed of queries, for example, in YQL or Greenplum, it does not differ in any way. It will not be true. Obviously, due to data locality and other features, Greenplum works faster. Does this justify an increase in the complexity of the system as a whole? It is also a difficult question, because it is necessary to be able to evaluate it, to set up some experiments. Maybe we'll get to them someday. Therefore, the simple answer is that we are not planning to abandon Greenplum right now. Here it complements YT well where normalization is required, a small number of joins, and where the speed of executing analytical queries with these same joins is required. Here. Actually, it originated for this and continues to be used for that. There is a question: what BI systems do we use to visualize data? We are using them now as a data lens. It natively works natively with YTsaurus. Basically everything. Before that, we had Tableau. But it doesn't know how to work directly with Chit. It can work with ClickHouse over YT. Can ClickView be used as a tool? In general, in my opinion, you can use any tool. Oh no. Well, I probably can't answer for sure. There are GDBC, ODBC drivers in ClickHouse over YT. Accordingly, if the tool can work with them, then yes, it can be used. The same with Spark. Spark sometimes also integrates with BI tools if they have their own kind of internal side, in which you can load some pre-calculated aggregates and so on. That's when everything will work too. But I don't have the expertise in working with ClockView, for example. So, another awkward pause. Any other questions? We should have came up with some funny YTsaurus stories to fill these pauses. What is a data mart? The data mart is some kind of preprocessed one. More precisely, it is preprocessed data that is collected according to certain business needs, and allows you to answer various questions there. In other words, an analyst can, on the one hand, write a complex query himself, collect a bunch of tables, joins, and get an answer. But if this happens often, it is much easier to assemble a data mart that will contain all the necessary data, well documented, well calculated, and the user will use them instead of making joins. But again, the same BI tool better use a data mart, or rather data marts, because we cannot send these complex requests every time so that they are executed every time with any request. How we share what goes in GP and YT. Well, in fact, we divide it first of all by layers, that is, we have a raw layer and an ODS. Or rather a raw layer exclusively in YT, because it is large and voluminous. Most of the odds we have is supplied to both Greenplum and YTsaurus because, well, more precisely, we do not supply only the fattest ODS, which simply physically will not fit there. The detailed layer is completely on Greenplum, because such a hybrid model is used to load it, something between a data vault and an anchor, and there is a very large denormalization there. It is difficult to implement this. But at the same time, there are also certain data marts in YT, which are calculated on top of the bold ODS. And therefore they too, well, as if their place of calculation is YT, and then, if necessary, they fall into the Greenplum, or do not fall, if not as necessary. I would probably add here that our main task for a long time was to make it convenient and good for analysts. and we tried to provide them with the most reasonable completeness of data in the systems in which they work. That is, for example, for some fast ad hocs, Greenplum is perfect, so they tried to pour everything to the maximum there. The fact that it didn't fit there, because after all there are expensive disks, and it's unreasonable to pour some logic or raw data there. We don't put it there accordingly. All the data marts that are considered on Greenplum, almost all are exported back to login. Because an analyst often needs to get used to these biggest scary logs for various kinds of research. The same click stream. And this is a task for which YT, of course, is better suited. Additionally to the data marts, it is said enough to ask that there are much fewer of them. Well, yes, there are much fewer of them because there are a lot of raw objects. Conditionally, there are many source systems, microservice architectures. Each microservice has its own database, which leads to a separate ODS object or raw object. And that's why there are much fewer data marts, because all these different sources are consolidated, counted. And a single object is obtained in which you can get, as it were, the correct version of the truth. There was probably also in the question that 300 is still a lot, but here we are talking about several fairly large businesses. We're talking about taxi, food, shop, delivery. There are a lot of people, a lot of different kinds of systems, a lot of subject areas that are being closed. So yes, it's difficult. Due to the fact that it's all complicated and scary, and does not fit in the brain, we are developing related projects that help to cope with this. For example, the said directory. Because it's really bad without it. Now it's getting easier with it. So this. Kalya, it seems to me, there was also a question about the number of memory cores. I do not know how much it is. But we can't say the exact numbers. It's still part of a trade secret. Here, perhaps, we can say the order. That is, roughly speaking, the CPU is measured in several tens of thousands. Here in aggregate, memory most often goes with us, according to the standard recommendation, of the order of 3 or 4 gigabytes per core there. Well, by the memory you mean operational. Because it's here. Well, probably, yes. So, here at the Black Swans, I didn't understand. Where should they be fixed? And, Trina, to be honest, I haven't tried over the top, but it's just not entirely clear what a black swan is, in the context of the taxi business. Business, but rather in the context of technology. In other words, I understand this concept itself. I can't add anything about Trina either. That is, I know that it exists, I have not used it myself. Most likely, it is unlikely to work by itself. But again, only click house over YT out of the box. Colleagues, any more questions?